Hello, this is Dr. Hanaa Assil, and this is the paper of Unit 1, June 2022 from the Pearson Edexcel IAS. So let us take a look at the questions and discuss the answers. The first question says, elements in their most stable state exist as what? What are the choices that we have? Giant, molecules, isolated atoms. Actually, elements in their stable state can exist as isolated atoms and atoms in molecules and atoms in giant structures. So these are all different forms of elements. So our answer is D. Then he says a sample of nitrogen gas contains this number of molecules. What is the mass? Now you remember the number of, in order to get mass, of course, we need to get number of moles. And the number of moles with respect to Avogadro's constant is the number of moles is the number of molecules over Avogadro's constant. So using that number of molecules, we can get the number of moles, and then he wants the mass, and you should know that mass is number of moles times mr. Remember, this is nitrogen N2, so that is 14 times 2, so that means that the mass is 0.56. When magnesium oxide reacts with dilute sulfuric acid, this is the equation. What is the ionic equation for the reaction? How do we write ionic equation? So he gives me this equation. Magnesium oxide is a solid, sulfuric acid is aqueous, magnesium sulfate is aqueous, and water is liquid. Now, remember that in order to write ionic equations, we ionize only the aqueous. So the solid remains as it is, the liquid remains as it is, and we ionize what? We ionize sulfuric acid, so that is 2H plus, sulfate ions, magnesium is magnesium 2 plus and sulfate ions, and then we cancel what is the same on both sides of the arrow. So you have sulfate ions on both sides of the arrow that can be cancelled, and that gives me the net ionic equation, and that is the one in B. A solution of sodium chloride is prepared by dissolving 10 grams of the solid in water, making up the solution to 250 centimeter cubed, and he's asking me what is the concentration. Of course, you should know that in order to get concentration, we need to get number of moles. So number of moles, in this case, he gives me 10 grams. So the number of moles is mass over molecular mass. That is 10 over the mr. He already gives me the mr. Please pay attention so that you don't waste time calculating the mr. That gives me the number of moles. Now I can get concentration from that. You should know that concentration is number of moles over volume, and that gives me the concentration. Okay, 10 test tubes, each containing 1 centimeter cubed of chromium chloride solution of concentration 0.1 mole per deciliter cubed, were placed in a test tube rack. Different volumes of silver nitrate of concentration 0.1 were added to each test tube, giving a precipitate. The precipitates formed were allowed to settle and their heights measured. Remember, this kind of experiment is when I keep adding more and more of the silver nitrate until no more precipitate can be formed. So he's asking, what is the formula of chromium chloride? Well, in order to get the formula, I need to get the number of moles of chromium and the number of moles of chloride, and then I can calculate it as if I'm getting empirical formula. So how do we get number of moles of the chromium? Well, he gives me up there 1 centimeter cubed of chromium solution of concentration this, so I can get the number of moles of chromium chloride, concentration times volume, and you should realize that that would be the same as the number of moles of chromium ions. So now I have the number of moles of chromium ions. How do we get number of moles of chloride? Well, we look at the volume of silver nitrate needed. So in order to look at this, and we find that the volume of silver nitrate, the maximum volume of silver nitrate that gave precipitates, is 3 centimeter cubed. So that would be the volume in order to get number of moles of silver chloride times the concentration that he gives me up there, 0.1. So this gives me number of moles of silver chloride, and that is the same as the number of moles of chloride. So now I have chromium to chloride. We divide by the smallest, and that gives me a ratio of 1 to 3. So my formula is CrCl3. The atomic number of scandium is 21. The mass number is 45. What is the number of electrons in scandium plus 1? Now, number of electrons is from the atomic number or the mass number? It's from the atomic number. He gives me the atomic number is 21, but this is scandium plus. That means it has lost 1 electron, and that means the number of electrons in scandium plus is 20. In a mass spectrometer, scandium forms scandium plus 1 and scandium plus 2. What is the M over Z value for the mass spectrum peak due to scandium 2 plus? Well, you realize that the mass number, he gives me that the mass number is 45. Now, M over Z, in this case, what is Z? Z is 2. Can you see that Z is the number of electrons lost or the charge on the ion? So M over Z would be 45 over 2, and that is 22.5. Which equation represents the first ionization energy of iodine? Now, let's remind ourselves, what does ionization energy mean? Ionization energy is the amount of energy required to remove the most loosely bound electron. So we're removing 1 electron to form a positive ion. We have first ionization energy is when it loses the first electron. So it forms 1 positive. The second ionization energy is when it loses a second electron, so it forms 2 positive. So he's asking about what? He's asking about the first ionization energy of iodine. That is when the gaseous atom loses 1 electron. Okay? What is the electronic configuration of a nitrogen atom? Okay, we look at the periodic table. Nitrogen has an atomic number of 7, so it has 7 electrons. Now, how are we going to distribute the 7 electrons? Remember that in the 1s, it is paired. It cannot be the same spin, so it has to be opposite spin in the 1s, opposite spin in the 2s. And then we have 3 electrons left, and that goes into one of each of the 2 p's, and all of them would have the same spin because they are in different orbitals. The element manganese has the atomic number 25. What are numbers of s, p, and d electrons in an atom of manganese? Well, if he says atomic number is 25, that means I have 25 electrons. Now, how are they distributed? They are 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. That is the electronic configuration. Okay, he wants how many s, how many p, how many d. You can see the s's are 2 plus 2 plus 2 plus 2. So we have 8 s electrons. How many p's? We have 6 plus 6, that's 12. And we have 5d electrons. Okay? Which row in the table shows the correct forces in a crystal of lithium iodide? Okay, he's saying, does it have attractive forces between ions with opposite charges? Yes, lithium iodide would have positive ions and negative ions with attractive forces between them. Does it have repulsive forces between ions with like charges? Yes, if ions are of like charges, they will repel each other. Do we have some covalent character? Yes, because lithium is a small positive ion, iodide is a large negative ion, so there will be polarization and therefore there will be some covalent forces between them. Okay? Some physical properties of 5 substances are shown. Which of these substances could be metals? Well, how do I decide if something is a metal? Remember that a metal would conduct electricity when solid. So the ones that conduct electricity when solid must be metals. Which substance has properties showing that it changes from molecular structure to ions when it dissolves in water? Well, let's look. What does this mean? If it changes from molecular structure to ions, that means as a solid or a liquid, it does not conduct electricity. It will conduct electricity only when solution in water. So which one conducts electricity when in solution? That is Q. At 180 degrees Celsius, aluminum chloride exists as Al2Cl6. What is the structure? If you remember, we said aluminum chloride has this kind of structure where we have bonds between two of the AlCl3 with another AlCl3 because the chlorines have extra lone pair of electrons that can be used to make bonds. So which of these applies to the options that I have? That is number C. When carrying out chemical experiments, hazards and risks must be considered. What is a hazard and what is a risk? Remember, a hazard is something that's harmful. So anything that is harmful, a chemical in the lab or a substance that is harmful, that is a hazard. Now, the risk is the chance that this hazard will actually be harmful. So we could have something that is harmful, but we take safety precautions so that there is no risk or there is less risk. So the hazard is fixed. It is either harmful or it's not harmful. But the risk can vary depending on our safety precautions. Heterolytic fission produces what? Let's remind ourselves. What is homolytic fission and what is heterolytic fission? Homolytic means the bond between them is broken so that one of the electrons goes to each of the atoms. Now, that means that it forms free radicals, the ones where we have one electron extra on each of them, that's a free radical. So, homolytic will give only free radicals. Heterolytic is when both electrons of the bond go to one of the atoms. So this results in the formation of ions. So he is asking about which one? Heterolytic. Heterolytic forms ions only. A hydrocarbon has a molar mass of 98 grams per mole. When a sample of X is shaken with bromine water, the color of the bromine water does not change. Now, which of these could be the structure of X? So first of all, he's saying the molar mass must be 98. So we need, first of all, to see which one has molar mass 98. If we count the molar mass of this, it's actually more than 98. This one is more than 98. This one is 98. But then he said when it is shaken with bromine water, there is no change. This tells you that there is no double bond between the carbons, so it cannot be C. Now, if we look at D, the MR is correct and there is no double bond, so that is our answer. Which of these atmospheric pollutants is not emitted during combustion of alkane car fuels? Okay, combustion of alkanes would give what? You should realize if we burn an alkane, it will release carbon dioxide. It will release water. It will release nitrogen dioxide because of the reaction of nitrogen and oxygen in the air. It would release sulfur dioxide because most of these fuels have sulfur impurities. It will give unburned hydrocarbons like octane. But he's saying which of this is not emitted, it would not give ammonia. Which of these occurs in a propagation step in the reaction of methane with chlorine? Well, do you remember the reaction of methane with chlorine? It was a free radical mechanism in which we have an initiation step, a propagation step, and a termination step. Now he's saying which of these is in the propagation step? Well, if you look at all the choices, this is one of the propagation steps. What is the IUPAC name for the compound with this structure? Okay, how do we name this structure? First of all, it has how many carbons? It has 4, so it is bute. It has a double bond, so it is ene, and the ene is on carbon number 2. Now, it has a chloro substituent on carbon number 2, so it is chloro, 2-chloro, bute 2-ene. And these are all the choices, 2-chloro, bute 2-ene. But then, is it cis or trans or E or Z? Well, let's look at it. If you look at each of the carbons and you decide which of the substituents has higher molecular mass or atomic mass. For example, on the right, chlorine has higher mass number than carbon. On the left, the carbon has higher mass number than hydrogen. And that means this is an E or a Z. Is it an E or a Z? It's E. When they are on opposite sides of the double bond, then this is an E. We don't say it is trans because the two carbons are not bonded to the same types of groups. So if instead of chlorine I had a hydrogen, then I could say whether it is cis or trans. The element iron forms two chlorides, FeCl2 and FeCl3. A known mass of iron powder is added to 200 centimeter cubed of a hot solution of iron 3 with this concentration. When the reaction is complete, the solution only contains iron 2 chloride. And he's saying the initial mass of iron powder was this, the final mass of iron powder was this. Calculate the number of moles of iron that react. Well, in order to get number of moles, we get the mass first, and of course the mass is the difference between the initial and the final. That is the mass that reacted. Now, what is the number of moles? Number of moles is mass over molecular mass of iron. That gives me the number of moles of iron. Calculate the number of moles of iron 3 that reacted. Well, what did he say? He said the iron was added to 200 centimeter cubed of iron 3 with this concentration. So how do we get number of moles? Number of moles is concentration times volume. Remember to divide the volume by 1,000 to change it to decimeter cubed. So this gives me number of moles 0.1. Then he says, use your answers to write the ionic equation for the reaction, include state symbols. You must show your working. Okay, what was the reaction? The reaction was iron, which is a solid, plus iron 3, which was aqueous, and he said the only product is iron 2. So this is my reaction. Now, in order to balance it, let us take a look at the ratio of the number of moles. We calculated the number of moles. So divide by the smallest. This is a ratio of 1 to 2. You need to do this because he says use your answers. So you don't just balance directly. So this would be the balancing of the equation. Now he wants it in ionic equation. How do we ionize? We said the solid remains the same. Only aqueous solutions are ionized. We break it up and we cancel whatever is the same on both sides of the arrow. So this is my net ionic equation. Okay? The concentration of the solution obtained in A is increased by heating it gently to remove some of the water. The solution is allowed to cool. Pale green crystals of this are formed. Analysis shows that these crystals contain 28.1% by mass of iron. Calculate the number of moles of water of crystallization X. Okay, so what do? We get the number of moles of iron. He's saying it's 28.1%. So assume that we have 100 grams, then my number of moles of iron would be this. This means that the mass of chlorine, this is the same number of moles. Remember, the number of moles of iron would be the same as the number of moles of the Cl2. So you can use it to get the mass of chlorine and then subtract everything from 100 to get the mass of water. Number of moles of water would be this mass over the mR, and that means I have the ratio of number of moles. We need to simplify it by dividing by the smallest. It comes out 1 to 4, so X is 4. Naturally occurring bromine has two isotopes. What is meant by isotopes? Do you remember the definition of isotopes? Isotopes are atoms of the same element having the same number of protons but different number of neutrons. Or you could say same atomic number but different mass number. Okay, complete the table to show the numbers of subatomic particles in the two isotopes of bromine. How do we get number of protons? Remember, you need to look at the periodic table. Find out what is the atomic number. The small number from the periodic table is 35. So in both cases, the number of protons are 35. And that is also the same as the number of electrons. Now, how do we get number of neutrons? It is the mass number minus 35. So 79 minus 35 and 81 minus 35. Okay? The mass spectrum of a sample of bromine is obtained. Draw a dot and cross diagram to show the bonding in a molecule of bromine, and he wants only the outer electrons. Okay, we look at bromine in the periodic table. It's in group 7, so it has 7 electrons in its outer shell. It needs one more, so each of the bromines will share one electron with the other one. So this would be your dot and cross diagram. Describe the formation of the molecular ion of bromine in the mass spectrum. Now, what happens in the mass spectrum? Do you remember what happens in the mass spectrum? The first thing that happens is ionization. So he's asking, how do we do ionization of bromine? Well, this is by bombardment by a beam of high energy electrons. So the first thing is the sample is vaporized, so it becomes a gas. So the gaseous bromine molecules are then bombarded by a beam of high energy electrons to break it up into ions. So the bromine loses one electron to form the molecular ion for Br2. On the mass spectrum, draw the peaks for the bromine molecular ions showing the relative peak heights. He's saying the bromine isotopes have the same relative abundance. So what are the choices that we have? These are the different choices. Remember, we have two bromines. Well, he's saying I have two isotopes, 79 and 81. So are they both 79? In that case, the mass, the m over z will be 158. Or are they both 81? So it will be 160. Or one of them is 162. Or one of them is 79 and the other is 81. And I have two options there. And that means the relative abundance of the peaks. If the one at 158 is 50, then the one at 162 is 50. The one at 160, that is the one in which one of them is 79 and the other is 81, and we have twice the possibility, so that would be twice the height. The percentage abundance of the isotopes are given. Calculate the relative molecular mass, and he wants it in 2 decimal places. Again, how do we calculate the molecular mass from the percentage abundance? Well, it's the mass of the first one times its abundance plus the mass of the second one times its abundance over 100. Then I need to multiply that by 2 because he's asking for the molecular mass of bromine, which is Br2. Elements carbon and silicon both form dioxide. Carbon dioxide is a simple covalent molecule. Silicon dioxide has a giant covalent structure. Describe the covalent bond between a silicon atom and an oxygen atom in silicon dioxide. Remember, we know that silicon dioxide is covalent. It is giant. We have a covalent bond between the silicon and the oxygen. So basically, he's saying describe the covalent bond. What's a covalent bond? It's the strong attraction forces between the shared pair of electrons and the positive nuclei of the atoms. This is what we say when he says, what is a covalent bond? Then he's saying compare and contrast the covalent bonding in carbon dioxide and in silicon dioxide in terms of orbital overlap. What is happening? Remember that if we have only single bonds, then we have sigma bond, which is an overlap head-to-head between two s orbitals or an s and a p. If we have a pi bond, that is, if we have a double bond, remember a double bond is sigma and pi. A single bond is only sigma. Now, what is the pi bond? It is from side to side overlap of p orbitals. So this is what he's saying, compare and contrast. Carbon dioxide is a double bond. Silicon dioxide would form single bonds. So both of them contain sigma bonds involving head-to-head overlap. But the carbon dioxide has a double bond, and double bond means I have both sigma and pi, and the pi involves side-to-side overlap of the p orbitals. The shape of carbon dioxide molecule affects its physical properties. Explain the shape of the carbon dioxide molecule. What is the shape of the carbon dioxide molecule? You should know that it is linear. Now, why is it linear? Because I have 2 sets of bonding electrons and no lone pair of electrons on the central atom. So it is linear in order to have minimum repulsion between the electrons. So remember, this is how we explain why it is linear. Explain the polarity of the carbon-oxygen bond. Why is the carbon-oxygen bond polar? You should know that this is because oxygen is more electronegative than carbon. So carbon will be slightly positive, oxygen would be slightly negative. Now, state whether or not the carbon dioxide molecule as a whole is polar. In the other question, he was talking about the bond. Now, is the molecule polar? Of course, if you look at the molecule, it's linear and the polarities are in opposite direction. So actually the polarities cancel, so the molecule is not polar. Are we following? So molecule as a whole is not polar since the dipoles are in opposite directions, so they cancel each other. The structure of silicon dioxide may be referred to as a diamond structure. Using your knowledge of the structure of diamond, suggest how the structure of silicon dioxide is similar to that of diamond. Why do we say that silicon dioxide is similar to diamond? Because both of them have giant 3-dimensional tetrahedral structure, but the difference is diamond has each carbon covalently bonded to 4 other carbons, while silicon dioxide has each silicon covalently bonded to 4 oxygen atoms, and each oxygen atom is covalently bonded to 2 silicon atoms. So actually the answer here is just that the fact that they both have giant 3-dimensional tetrahedral structure. Give a possible reason why silicon dioxide has lower melting point. If both of them are giant, and he's telling me that silicon dioxide has lower melting point than diamond, why do you think that? because silicon dioxide would probably have fewer bonds per molecule, so less energy is needed to break the bonds. That would be why it has lower melting point. This molecule is a compound that gives ginger its characteristic flavor. Its IUPAC name is this. On the structure, draw a circle around the 2-methyl group referred to in the IUPAC name. Where is 2-methyl? He says it's 2-methyl, 5, a lot of things, cyclohexadiene. So the 2-methyl is on the cyclohexadiene, so that is this one. Deduce the molecular formula of this compound. Well, look at it, put in all the carbons and the hydrogens, count them, they will come out to be C15H24. When this compound reacts with excess hydrogen bromide, there are a number of possible products. The structure of the major product is shown. Name the type and mechanism of the reaction. What did he start with? This is what he started with. So he's adding HBr to this molecule, and this molecule has double bonds. So when we add HBr to a double bond, this is electrophilic addition. Then he says the diagram shows a simplified structure of the compound. Complete the mechanism for the reaction with one molecule of hydrogen bromide. So we're adding HBr, electrophilic addition, and that means the first thing is the double bond. Electrons from the double bond go to the slightly positive hydrogen, and the electrons go to the slightly negative Br, and then that forms a Br minus that attacks the carbocation. Now, for the reaction, there are two possible products. Either the Br is on one end or the Br is on the other. Now, explain why structure 1 is the major product by referring to your mechanism. How do we get structure 1 or how do we get structure 2? Remember that structure 1 would be formed from a tertiary carbocation, and a tertiary carbocation is more stable than a secondary, so usually the one formed from the tertiary carbocation is the major product. Okay, then he says this reacts with hydrogen gas, so he has the double bonds and he's reacting it with hydrogen gas in presence of a catalyst. So what is the catalyst when we add hydrogen to a double bond? Remember, it's hydrogen in presence of nickel catalyst. Then he says 2 mole of the compound react completely with hydrogen at 150 degrees Celsius and a pressure of 120 kilopascal. Calculate the minimum volume of hydrogen needed. So, first of all, he has 2 moles of the compound, but this compound has 3 double bonds. So, for each molecule, I actually need 3 moles of H2. So if I have 2 mole of this, then the number of moles of hydrogen is actually 2 times 3, which is 6. Then I can put it into the ideal gas equation. He wants volume, so this is nRT over P. The number of moles of hydrogen is 6. R, he gives me 8.31. Plus the temperature, 150. Remember, you need to change it to Kelvin, so you add 273. The pressure should be in Pascal. So if he gives it to me in kilopascal, I have to multiply by 1,000. So that gives me the volume in meter cubed. Organic waste may be disposed of by landfill or incineration. Remember, landfill means I'm going to bury it in a ground somewhere. Incineration means I'm going to burn it. Both processes produce gases. Now, the main gases produced from a typical landfill, so this is by burying the wastes, this will give these percentages of gases. Name the process that forms these gases in the landfill. When I bury the waste in the ground for a long time, what happens to them that gives out these gases? We call it decomposition. Remember, the bacteria break it up, fungi break it up, and so on. So this is decomposition. Okay, state the main environmental problem caused by landfill gases. Identify the gas. Remember, the main problem from these gases is the global warming. And you remember that global warming is due to the increase in percent of methane and carbon dioxide in the air. 1 ton of landfill waste produces approximately 12.5 decimeter cubed of gases per day. Calculate the mass of carbon dioxide produced in a year by a typical landfill site that contains 90,000 tons of waste. Okay, so what are we doing? He says 1 ton will give 12.5 per day. So you have to find out per year because he wants the mass of carbon dioxide produced in a year. Okay, so this is the amount in a year by 1 ton. But he says I have 90,000 tons, so you multiply by 90,000. And then we look at, he's asking about what? Carbon dioxide. He gives me in the table that carbon dioxide is 45% of these gases. So this is not all carbon dioxide. Only 45% of it is carbon dioxide. So I can get the volume of carbon dioxide. And then what does he want? He wants the mass. Well, I need to get first the number of moles. Number of moles is volume over 24. And then I can get the mass, the number of moles times MR. That gives me 338.77 tons of carbon dioxide. So just 2 advantages of incineration over landfill. Okay, if I don't bury it, I burn it. What advantage would that be? That means I'm using up less land. The burning or the incineration can be used to generate electricity. Or you could also mention that burning it will eliminate harmful bacteria. And burning is the only way to get rid of non-biodegradable polymers. Remember that non-biodegradable polymers, if they are allowed to stay in landfills, they will stay forever. They're not broken down. Environmental groups prefer recycling to both landfill and incineration. So just one advantage of recycling. Well, one advantage would be it saves energy or that it conserves resources. And that was the end of this paper. I hope that this was helpful. Thank you for listening.